In this video, we're going to look at digital and analog signals, that is digital electronics. Now, analog signals are electrical representations of quantities which vary over a wide range of values, e.g. a sound wave. The amplitude and frequency vary continuously over a wide range of values. Parts of the analog signal have any value in a range. So an analog signal, that's what's shown here. Positive, negative values, positive, negative values. So they vary like they switch. If you remember the topic on electromagnetic induction and alternating currents, that's where I covered this. Now in digital signals, you find that the output can either be 0 or 1. 0 or 1. So these are binary values. So zeros are representing lows and ones representing highs. The signals are in the form of coded pulses. On-off switches, digital clocks, and digital meters are digital devices. You could name many more digital devices. Now, we're going to move on to talk about logic gates. Logic gates are high-speed switching circuits used in computers and electronic systems. They are made up of transistors and other components and are manufactured as integrated circuits, ICs, which are with each chip holding several gates. They have a high output or a signal depending on the combination of voltages at its input. A high output or input voltage is represented by the logic level 1, and low voltage, that is near 0, is represented by logic state 0. There are different types of logic gates, and the gates can be combined so that the output of one gate becomes the input of another. Truth tables are drawn to summarize the behavior of logic gates. So we're going to start with the first logic gate, which is the NOT gate. The other name for this is called the inverter. So whenever the input is high, the output is low, and whenever the input is low, output will be high. So the symbol for a NOT gate is as shown, a triangle with a NOT in front. So input 0, output 1, input 1, output 0. So that's the truth table for the NOT gate. This gate has one input and only one output. Then the next logic gate is the AND gate. Now AND gates have two inputs, A and B, and then they give an output of 1. They've got one output Y there. So the AND gate gives a high state output if both A and B are high state. So output is high when both inputs are high. So 0, 0 gives you 0 on the truth table. 0, 1 gives you 0 on the truth table. 1, 0 gives you 0 on the truth table. And 1, 1 gives you a 1. So when both inputs are 1, you get a 1. Otherwise, it will be 0. Now, to illustrate this AND gate, we can have two switches connected in series. And we have 5 volts entering in to the bulb. Now, if both switches are closed, that's when you can have the bulb switching on. If one of the switches is open, the bulb will not light. So a high output controls the motor, which then operates a lift. So this could work in a lift situation. That is, when both doors are closed, the input voltage to the gate are high, so the output will be high. Then we have an OR gate. In an OR gate, we have got, it's half moon shaped. Okay, it's unlike the AND gate. The AND gate had a straight line down there, but this one is moon shaped, so it's curved over here. So it also has two inputs and an output. So this one is gives an output of high when either A or B are high. That's why it's called OR gate. Either or. Either A or B has to be high state to give a high state output. So 0, 0 will be a 0. 0, 1 gives you a 1. 1, 0 gives you a 1. 1, 1 gives you a 1. The output is high when one of the inputs is high. The circuit helps to explain the AND gate. Now, if you have, so this one explains the OR gate, please. It's an OR gate over here, not AND. So if A is open, B is open, nothing goes on to the bulb. If A is closed, B is open, current flows in the path where there's A there. And then if B is closed, A is open, current will move through B to there. And when both are closed, current still flows to the bulb. So an OR gate can be used to control the barriers, bells, and lights at a railway crossing. If the train is approaching from one direction for the opposite or the opposite direction, or in both directions, there would be an output and the barriers would close. The bells and lights would come on to warn the cars of an approaching train. Then we have an NAND gate. A NAND gate is just an AND gate followed by a NOT gate. So the output is opposite to that of an AND gate. When both inputs are high, the output will be low. So 0, 0 will give you a 1. 0, 1 will give you a 1. 1, 0 will give you a 1. 1, 1 gives you a 0. Remember, in the AND gate, only the 1, 1 state was giving you a 1. In the AND gate over here. So only a 1, 1 was giving a 1 there. So the NAND gate inverts this AND gate to give you 1s where there were zeros and 0 where there was a 1. Right, then we have a NOR gate. A NOR gate is an OR gate followed by a NOT gate. Again, it's the opposite of an OR gate. So where there was 0, 0, we're now getting a 1. 1, 0, or 0, 1 is 0. 1, 0, 0. 1, 0, 0. So a NOR gate is the opposite of what was going on an OR gate. So the output is high when both inputs are low. Right. Now using logic gates. Gates can be combined together to produce a circuit to control a system. An example is a security lamp, which is designed so that it comes on in the dark and when someone approaches. In the dark and when someone approaches. So the fact that we've got an AND, it means we need an AND gate. So we need a light sensor. Remember we talked about LDRs. And also we need something that can detect the presence of a human being. So you'd need an infrared sensor, which is in the form of a body heat sensor. So we place our light sensor over here, which is our light sensor, and then we have a body sensor over there. And then immediately we have a NOT gate following that. So which means if there's light, then the output comes as 0. If there's darkness, then the output comes as 1 there. So it is dark, so which means it gives a signal because of the NOT gate that has been connected in front of it. And then that one signal goes to the AND gate, then waits for this one. So if there's someone approaching, that means that the body sensor will then emit a pulse. So it will be a 1. The 1, 1 on an AND gate gives you a 1. And the relay, remember the purpose of a relay, a small signal comes from there, and then it's connected to, the relay is connected to another circuit which can then make this lamp to go on. So That's how this circuit works. A relay is used because the gate does not supply enough power for the lamp. Okay. So this is how you can do it. You could make a truth table, and then you put the figures down, and then the one that gives you a 1 would be the one that you work with. Since I had already done it, there's no need for me to go over it again. Now, I hope you have understood the topic, and looking forward to having some questions or comments in the comment section. These are questions that relate to the topic. If you can find some time, just go over each and every. You just pause the video and go over the questions and make sure that you do not have any problems with any of the content given there. Right. So I think that is it. Just about time for me to sign out.